My name is Mario Cosmo and I work at the Italian Space Agency. And the session that we're about to have is about COSMO-Skymed, about the dual approach used for this program, and on the achieved results as we move along the exploitation of the current constellation and preparing for the second generation. You know that among the various unique results of COSMO-Skymed, we have a very performing constellation in orbit, different products, various products, high resolution, and at the base of all these there is the dual paradigm. So the civil sector and the defense got together to build this fantastic system. I'd like to welcome our speakers. We have Mr. Coletta, who is the COSMO-Skymed Mission Director in IAC. We have Mr. Denimura, Project Officer for Space Programs at the European Defence Agency. We have Mr. Maranesi, President of IGEOS. We have Mr. Rivola, Colonel Chief Officer for Space System, Ministry of Defense. And at my right, we have Mr. Kamiyama, President of Japan Space Imaging. Thank you very much for coming. And I'd like to start, if you agree, talking about the civil part and the civil performance of this system. So I'd like to give the floor to Mr. Coletta from the Italian Space Agency. Mr. Coletta.
Okay, can you hear me? Okay, I am Alessandro Coletta, I'm the COSMO-Skymed Mission Director. I just want to give an overview, a quick overview of the COSMO-Skymed system, just to introduce next speakers and next presentations, and focusing some main elements of the system. First of all, the dual nature, intrinsic dual nature of a COSMO-Skymed system. So, it's well known that the COSMO-Skymed is the first worldwide example of Earth observation program that has been conceived, developed and realized for full dual application, which means you have to satisfy two different domains, the civilian domain and a defense domain. But this not means a simple exchange of technologies. For example, military technologies transfer on the civilian side. But it's something more, is a dual implemented as a real modus operandi, which means, what does it mean? It means sharing technologies, financial and human resources to develop a system that is intrinsically complex. This also means that you can have a successful activity only if the dual approach starts from the very beginning of the system developing. So, since the early phases, which means also to have integrated teams, integrated program office, people working together just to understand the main requirements for satisfying the both sides' need. So, what is COSMO-Skymed? It's the most challenging program ever conceived, developed and realized by Italy, and has been developed by the national industry and managed by Italian Space Agency together with the Ministry of Defense. This means to have some main requirements that base the developing of all systems. So satisfy, as I told before, satisfy the both sides' needs, have very top-level performances, for example, short response time, maximum flexibility on covering a larger area coverage, on high resolution. And what is very important is the system that characterized by the expandability, which means it's not a closed system, but we are open to new partners for both sides, both civilian and both defense. So this is what is a general schema of the architecture, which in its symmetric view shows the balancing of the two parts, because we have some common device features, some single domain features. This means that the space segment is common, while the ground segment is made of different kind of parts. There's something that is common between Italian civilian and defense part, and something that is only single domain oriented. So, first of all, the common space segment. As you know, we have 4 synthetic aperture radar satellites operating on 9.6 gigahertz, orbiting in a sun-synchronous orbit, allowing a worldwide coverage and all-weather night and day acquisitions. COSMO-Skymed is unique. It's the only constellation now operating with 4 satellites in this kind of scenario. And having a constellation of 4 satellites means, what does it mean? It means have at least 4 acquisitions per day in the worst condition at the equator. But the higher is the latitude, the more the daily passes we have. This means that at our latitude, so we have an average revisit time of about 4.5 hours, which means at least to have 20 passages of the satellites in the same geographical zone every day. And only COSMO-Skymed can allow this at present time. So we have also a very huge amount of images that can be collected at the level of the space segment, going from very large coverage area from 2,200 by 200 kilometers SWAT with 100 meters resolution up to very high resolution mode with smaller SWAT, 10 kilometers by 10 kilometers. This is always from the civilian side. From defense side, we have also a better level of resolution. We can acquire at space segment level up to 450 images per day, which means 1,800 images for the whole constellation. And from the ground segment point of view, we have something that is shared together and something that is only single users, single domain oriented, as I told before. So we have a common infrastructure between the Italian Space Agency and the Ministry of Defense, both at the level of control station and downlink station. So we have to cover all the orbits of the satellites, 15 orbits per day. We have a station all over the world in different parts. So we have the main control station in Fucino in Italy. Also another station, a remote station, a higher latitude in Kiruna, Sweden, and another one in Cordoba in Argentina, just to cover all the passages per day. At the level of user ground segment, we have different parts. We have a civilian downlink station in Matera, level of civilian domain, and other in the defense domain, including also, you see not only the Italian defense downlink station, but also the France downlink defense station that we have in the baseline scenario, thanks to the cooperation that I told at the very beginning of this presentation. We've also mobile stations, at both civilian and defense level, so mobile acquisition and process station that you can move everywhere you want, in every theater of operation that you need. So just to acquire directly data from the satellite, archive, processing, and distribute data. An evolution of this original scenario is the actual scenarios, including the portable user terminal, so something that has been developed just to satisfy the maximum the needs of the single user. So you can get, if you're an authorized user of COSMO-Skymed, you can get just this light user ground terminal, and you can satisfy the needs that you have, just from starting from programming, acquire, archive, and distribute data. This means this allows a near real-time scenario, close to 30 minutes from the acquisition, the delivery of the products, just about 30 minutes after the acquisition. The constellation is fully operational. The first satellite was launched in 2007, the last one in 2010, and now it's completely operational. So up to today, that it's the 5th of October, and I want just to give you some numbers, some operational life numbers. Exactly now, it was at noon, but it's a quarter to 1, it's okay. We have an amount of a total volume of about 90,000 orbits orbited from all the constellation, with more than 11 millions of telecommands uplinked during this operational lifetime. This from the system point of view. From the utilization, up to now more than 300,000 products that have been generated and distributed by the COSMO-Skymed system. And we have verified what some of the main characteristics of COSMO-Skymed: unique capabilities of the fast response, the large long area coverage, interferometric revisit down to 1 day, few minutes between two subsequent collections for motion detection. Just an example of these things. This is just a feasibility study of what occurred during the Tohoku earthquake in the 11th of March 2011. We have a cooperation with the Japanese Space Agency, and we were requested of about not more than 4 images during this emergency, but we provided in a few weeks more than 200 images to our colleagues in Japan. Also collecting in less than 1 hour very long strip of data. For example, the longest strip was 700 kilometers in just 100 seconds. So a very large amount of data quite in a few time. Another example of this one, it will be better showed by next speaker, Mr. Marcello Maranesi. This is the north and east passages that we acquired. This is the image. We acquired in more or less 30 hours. So large coverage in very so it's a fast, large, long area mapping in general. Another example, this one for motion tracking. This is the mapping, the monitoring of a very big iceberg that broke off the Petermann Glacier in the Greenland in summer 2010. So we monitored the movement of this part of this iceberg during all summer in 2010. This is just an example of some acquisition. But what I want to stress is we acquired with 2 different satellites, COSMO-Skymed 2 and COSMO-Skymed 3, 2 images in just 18 minutes. This is the first one, this is the second one. This means this allowed to have a very good identification of the current pattern around the iceberg that in that moment was blocked by a rock in the channel, in the sea channel. So now I want to say something about how to access this system. So I described some characteristics of the systems from the technical point of view, but we have to access this with the system itself. So we have is a dual-use system, so you must take care of some important rules in this, and just accessing. So we developed how much time? 3 minutes, 4 minutes, 5 minutes. Okay. So we developed a specific data policy for data distribution, also considering the different cooperations that we have, and a resource sharing methodology between the 2 partners, just to ensure the maximum satisfaction by the 2 different domains. So we developed this ad hoc national data policy resource sharing, also defining a set of utilization guidelines or rules to access the system, and providing integrated ASI and Minister of Defense governance management. What is important is that these guidelines, these rules are continuously updated, following what we learn from the operational phase. So we have this governance management, considering just like a single body of what is both the civilian domain and the defense domain. So we have defense users directly satisfied by the defense domain, while in the context within the civilian domain we have 2 different subclasses, the institutional users that are directly served by ASI, and commercial users that are served by the EGEOS commercial provider. And we continuously dialogue between, there is a continuous dialogue between the two parts, the two domains, just to satisfy at maximum all the system needs. This is just an example of what is, from a high level, which kind of institutional users we are considering in the context of the ASI scenario. So we have as project in the national, international institutional users, also national, international cooperation. I will just mention these three. This is with France, with the Pléiade system, optical Pléiade system, with Argentina, with the other radar satellites in L-band and the next band, and the already mentioned cooperation with the Japanese agency, with the ALO satellite. We are waiting for the launch of the second ALO satellites in 2013, I guess, and in which we are operating with for disaster modeling. This means trying to develop systems that let in a multi-frequency approach from the optical or different radar bands. So, just one question that can arise that I heard very, very many times in these 5 years of operational life. This is, may a dual use system be characterized by some intrinsic problems? For example, the most obvious, the most trivial, is unavoidable conflicts between two different classes with different nature. So, I believe that you can answer only living directly in an operational manner these things. Otherwise, it's impossible to answer this question if you are just around the table trying to develop and fix some general rules. So what I can say after 5 years, it is not true. There is not direct conflicts. But what I experienced was some, I can call them some side effects elements that was impossible to understand during the developing phase. Only leaving the operational phase you can understand which kind of tuning you must do at the system. This means that anytime we identify one of these kind of effects, we have a subsequent tuning of the common rules that I mentioned before. This means that at the same time, we learn a lesson. Just is a feedback, a continuously positive feedback, with two different outputs. The first one, we optimize the current CSK constellation utilization. The other one is this lesson learned is a requirement input for the next COSMO-Skymed second generation. Just to show you, in 2011 we have an 85% satisfaction and of the total amount of images we can acquire in the civilian domain, while after the tuning, continuous tuning, in this current year of the rules, the common shared rules, we went to the level of 95%. This is the current level of satisfaction of our acquisition of available images in the civilian domain. The second thing is the COSMO-Skymed second generation. So the first one of the satellites in the first constellation was launched in 2007, the last one in 2010, and we have the COSMO-Skymed constellation with 4 satellites fully operational from the beginning, about from May 2011. So, considering a nominal lifetime, 5-7 years for each satellite, we have to provide a replacement of the old ones with the new ones. And ASI and the Ministry of Defense are developing this new kind of the second generation. The phase B has been completed, and now is the phase C, and further phases under negotiation. Foreseeing the first launch in 2016 of the first one of the COSMO-Skymed second generation, 2 satellites have been considered. And with our learned lesson, we can reach a real improvement of the performances at each level, both ground, both the space segment, with introduction on new level of polarization, with improve the number of images we can acquire, SWOT of the different acquisition modes, and so on. So all these things coming also from the lesson learned, just to improve the overall performances. Just the last example of a common, on a real cooperation between in civilian side and defense side. Just considering one of the classical scenarios in which COSMO-Skymed provided a very valuable support in these years. This is the emergency scenario. Just to show you very quick some principle of the most important emergencies, considering earthquakes, volcanoes, eruptions, so on along the world. But just was to consider one, the Haiti earthquake in January 2010. Why this emergency? Because we cooperate really with the Ministry of Defense just to assess just to have a disaster assessment, understand the displacements in the area of Haiti using just an image coming from the defense, another one coming from us. So we put together the pre-event image coming from the Ministry of Defense, a post-event images from ASI, just to have a real view of displacement of the change detection that occurred in that event. So I believe that I'm in my 10 minutes. Okay, thanks. Thank you.
Thank you, Mr. Coletta. And now I'd like to give the floor, keeping on the civil applications, Mr. Maranesi, the floor is yours.
Thank you, Mario. Good morning, everybody. IGEOS is a company that Italian Space Agency and Telespazio decided to establish in order to promote the commercial exploitation of COSMO-Skymed. When we started a few years ago the activity of promoting Cosmo, we found 2-3 customers that we could finalize orders quite soon. Then a lot of interest, but difficult to finalize orders. The point is that everybody was interested in the applications of this technology, but it was difficult to implement those applications. Processing was quite difficult, tools not yet fully developed. So there was a great demand for the applications, for the utilization of the data, but was not enough capability to exploit. So what we did was to facilitate the development by ourselves and by other partners, other players, of a number of applications. And now we can say that there are a variety of applications in emergency risk management, defense, intelligence, agriculture, forestry, environmental monitoring, and so on, agriculture. As IGEOS, in combination with some of the European Union programs for R&D, we have engineered some of these applications. So we have prepared some kind of standardized workflow to generate reliable and operational application. And I'm going to concentrate now on these ones, which are basically covering emergency response, maritime surveillance, and the land monitoring. So emergency response is now a contract that we have got from the European Union on a competitive basis to provide service for damage assessment and after natural or man-made disaster. So it may cover flood, fire, earthquake, but an important thing is that this is now a service which is offered 24 hours a day, 7 days a week. And so it's really something that is used operationally, has been set up within the European Union in combination with the many civil protection entities. The most important one was the Italian that was coordinating these activities. So the most important thing is that when we produce some of these products, they are well known and received and used by the civil protections. It's not just a technological exercise. And some examples here, the first one is over Italy, the famous earthquake in Emilia. And actually here we have combined the satellite data with the very detailed aerial data, because we had this possibility to fly over the area at 10 centimeters and produce maps of this kind, very, very detailed, where the color green stands for houses not significantly touched by the earthquake. Yellow and red means, of course, more severe influence. This one instead is, even if it is a color image, is derived from a combination of multitemporal COSMO-Skymed and is relevant to flooding in Thailand. The second one is Maritime Surveillance, and here we are talking about monitoring the spill of oil in the sea and identification of ships that may be good for illegal immigration or again for identifying the polluter in the sea, and ice charting. Examples here are the hijacking of the D'Amato boat close to the Somali coast. And here we use the technique of combining ScanSAR, very large SWOT, low resolution, and then later on spotlight images with a very small imaging area. And we could identify through some simulation exercise the location of the boat that we have then passed to the Italian authorities. And about oil spill, here we have a case in Brazil where 8,000 barrels of oil were coming out from an oil rig. And through the monitoring that we did over 17 days, we have provided enough documentation to the Brazilian government to recover $28 million of fine from the polluter. So there is also very concrete return from the use of this type of techniques. The last one on the maritime surveillance about ice charting. We all know that the North Pole is getting more and more warm, so ice is melting, and the two passes, northeast and northwest, are becoming feasible, especially during summer period, for naval transportation, saving a lot of money because of with respect to the other routes. So knowing what is the status of the ice, knowing the major iceberg and their movement, it's very important in order to provide this type of service. And the third area of application is land monitoring. Here we are talking about monitoring the stability of infrastructures and doing multitemporal coherence mapping is a new technique. I'll talk to you in a while, that can be used for, let's say, both intelligence on one side, but also for thematic mapping and agriculture monitoring. Here we have the monitoring with interferometric processing. This is the case of the Russian railways over the Tuapse-Adler line, which is the one that is going to be used for the next Winter Olympic Games. You see, every point can be monitored step by step with an accuracy of a few millimeters. So we can monitor position and also speed of how they move. And of course, again, the color represents the danger that each of those points is moving on the terrain. So this is a system that provides the railroad information about the potential risk. Of course, it's not a real-time system, but especially after heavy rains, provides information whether something happened or not. Okay, here is multitemporal coherence for intelligence. By combining two images taken at a very close interval, we can understand what are the changes. So here we can see, for example, that inside certain hangars, if they are empty or they are, let's say, hiding airplanes or other facilities, because radar has the capability to penetrate plastic. And here we have a monitoring of activities. Because of the fact that we can measure displacement of millimeters, a car passing in a desert area leaves very clear tracks. And by doing this processing, which is a coherence processing, we can identify all what is white is coherent, so has not changed. What is black is changed. And we can determine which are the tracks used by cars or other vehicles. And by combining this with the existing information, so what are the usual routes used by vehicles and the ones which are not usual, we can derive information on what's going on, or at least give an alert information for somebody else to investigate further. And here we have an application about using this multitemporal coherence to increase the information content to understand what are the cultivations over a field. So somehow with the multitemporal approach, radar can recover information content that you get from the bands of an optical system. So users for these services, which are now very, very operational, are both institutions, and you see here a list of them, but also a number of, let's say, industrial operators, oil, gas, transportation, logistics, insurance. And all of this is important to say that all of this is really operational. So it's worldwide, it's guaranteed day and night, all weather conditions, thanks to COSMO-Skymed, is high frequency, is a faster revisit, and as I said before, is 24 hours a day service. And we have a number, 1 minute I finish. We have a number of results already obtained which demonstrate how customers like this type of operational service. So they know exactly what they're going to get, they know the timing they are going to get the service, they know the price, and of course there are different pricing policies, subscriptions, different geographic areas. And so they like something which is not anymore scientific but operational. So two things, all of this is based on multi-satellite data, but it's fundamental, the contribution of COSMO. Here, for example, you have all the possible acquisition over one day, and by concatenating the various acquisition over days, we can have a multitemporal coherence down to 12 hours. So knowing that somebody has crossed a certain area within 7 o'clock in the evening and 7 o'clock in the morning, it's quite useful. And here you have an example, something that Alessandro just mentioned. Within 17 hours, 61 acquisitions over the North Pole. So you can see the power of the system that, thanks to the 4 satellite constellation, can provide an unmatched revisit or large area coverage on a daily basis. So this is happening all in one day. Thank you very much for your attention.
Thank you, Mr. Marinesi, and let's end our overview of the civil part of the system with Mr. Kamiyama.
Good afternoon, ladies and gentlemen. My name is Kamiyama from Japan Space Imaging, and I'm very honored to be here to have my presentation because of Japan Space Imaging is representing eagles in Japanese market for the COSMO-Skymed data distribution for the defense and intelligence and commercial and civil customer in the Japanese market. Today, I would like to cover that 3 points. One is, first of all, that I would like to explain that who we are. Secondly, that I'm going to address that what we have been doing in terms of distributing COSMO-Skymed data in Japan. And last, I would like to make some recommendation, a comment on what we should do in the future in terms of distribution of COSMO-Skymed data in Japan. This is our company overview. Our company was established back in 1998. This was memorial year for the Japan because of we were hit by the missile from North Korea, and we had a very big problem on how we can deal with those threats from the North Korea. And at that time, the Japanese government could not own the own military satellite because of Japanese space policy, which had been, by the way, deregulated back in the year 2008. Though. But at that time of 1998, Japanese government, particularly MOD, cannot own the reconnaissance satellite. So that's why, we, Mitsubishi Corporation, invested our money into the space imaging venture, which is a high-resolution commercial data. And investing our money, we, took distribution right of the high resolution satellite data, which we deliver to the defense agency. And because of this is, huge opportunities, not only for defense and military purpose, we thought we can market to the commercial and civil market. So that's why we established the company Japan Space Imaging back in 1998. And the first generation, we distributed 1 meter high resolution satellite data for e-commerce data. And the second generation, we are dealing with the JWI, which is a half-meter resolution data for the optical satellite. And the year 2007, we got agreement with the Eagles so that we can distribute COSMO-Skymed data in the Japanese market. And in the future, we would like to deal with the Japanese developed satellite developed by the Japanese government, like AROS or ASNARO, so that we can distribute those data outside in Japan. This is what our product we are dealing with. This chart shows you, idea of what kind of function we have. We have a whole bunch of value chain from collecting, receiving data, archiving data, and dissemination data, depending on the customer. customers who would like to have data immediately, like defense and intelligence, we deliver the data as soon as we can, and having antenna in the Japanese island. And in the meantime, we archive the data so that we can deliver those data using internet or cloud or web system. So customer can access our database to use for the GIS and application too. Now I'm going to explain that what we have been doing in the past. Let me introduce two cases. This is rice field monitoring project, which is led by the Japanese Ministry of Agriculture, Fishery and Forestry. Government is now controlling rice harvest, and government is also paying some compensation to the farming house who contribute that policy by reducing rice harvest, decreasing acreage. And in order to pay money to these house farmers, Japanese government have to check and review whether or not that application from the farmer can be correct or not. So in old days, the Japanese government dispatched many investigators to the rice field to check the rice pad. That cost is huge, to cover the entire Japan. So, and then government is now considering to introduce the another method to check and review the rice field by using a COSMO-Skymed like satellite data. Something like this. This project is started the year 2010, and JSI together with the eagles took the 171 scene and collaborating with having support from ASI. So this is an idea. We took the two different season imagery. One is a ponding season in April and May, and the other one is the growing season in July and August time frame. And as you can see, ponding area is shown as the black. Meanwhile, that the seasoning growing area is showing white, so that you can understand that which area is not rice field. And because of by introducing this kind of method, the government can reduce the administration cost. That is the motivation for government to introduce this kind of application. Next one is the disaster management. Japan had lots of natural disasters, earthquake, tsunami, and also typhoon. I have two, application cases. One is, earthquake. Remember that we had a big earthquake on March 11 last year. We had a huge tsunami, and more than 20,000 people were lost. Actually, that March 11th, I had a meeting with my team in my office on March 11th in Tokyo. And soon after, I checked the safety of my employee to the, and then I have, asked the eagles to collect the data as soon as possible. And so this is one of the examples that, taking the, single data, we can see, check the disaster assessment. And this is a very good, data, so that we can manage the disaster assessment. In the meantime, data can be used for the, damage recovery This is an example of the shooting imageries for nuclear power plant of Fukushima, and we took the right after the earthquake and 1 year later. And comparing those two images, you can see that change part because of nuclear power plant required big water to cool down the radiation. So that's why that they have to cut off the forest, and the way they put the water tank. Blue one is the tank, and red one is the deforest area. This is another example, the typhoon, and we have a lot of typhoons, so that we have a problem of the, let's say, land sweep. We can check the, disasters damaged area. And now I would like to, recommend the two, point. One is the, I'd like to recommend to create entire Japan side data. Because of side data is better, we have, two images rather than just a single imagery. Because that, we don't have a good enough databases, so that even if you have a natural disaster, we cannot have two pair imageries as soon as possible. So second recommendation is that we need to create some platform for the, let's say, natural disaster management or maritime domain awareness. This is the kind of ideas. First of all, that we need to create a database to cover the entire Japan. And once we have this pre-event databases, when we have natural disaster, we can collect the imagery and then analyze the data using many methods like color, composite, and so forth. So this is can be used for the civil and commercial use for, let's say, utility company like electricity and Japan Railway. Because of we have an earthquake, we have lots of data for east part of Japan, but we don't have in the west part, so that we have to, prepare the good enough database for covering entire Japan. And this is the kind of idea how we can create the future disaster management system. In Japan, we have a problem of the maritime domain awareness. So because of we have a big issue like remote island and EEZ, we have number 6 in the world for the maritime domain. So this is the kind of a concept that we are going to proceed. We know the COSMO-Skymed together with REDASAT providing data for maritime domain awareness for EMSA, European Maritime Space Safety Agency. We have a lot of international relationship between the United States, Canada, and Italy. So that, and then the Japanese government is now trying to launch their own satellite. We can create this kind of platform so that we can provide that maritime domain awareness.
Thank you.
Grazie.
Okay, thank you, Mr. Kanema. Let's go now to the other side of the Cosmo paradigm, and let's hear our colleagues from the defense, Mr. Stefano Rivola from the Italian Ministry of Defense. The floor is yours. Okay.
Good afternoon. I'm Colonel Stefano Rivola. I am the Chief of the Space Program Office in the General Secretariat of Defense, and I'm here to provide my contribution to this discussion. And we are speaking about dual approach and achieve results. Of course, after the presentation of my colleague from the Space Agency, I cannot say avoid to imagine that you know already the results of my presentation, because of course the dual approach means also that we come to say share the results. So if there is a satisfaction from the space agency side, I can anticipate that this presentation will come to the same conclusion, that COSMO-Skymed was a success also for the defense. So now, knowing already the result, the scope is to analyze why it was a success. So I will try to show you my opinion, which are the basic elements that can be used as a sort of method to implement the duality concept. So to this purpose, I will address mainly three topics. A quick overview of the history of duality, some elements concerning the duality implementation, the ingredients of the success, and then at the end, the lesson learned. So starting from the history. The history starts at the beginning of this century, which the actors at that time, there were three actors. The defense, for sure, was interested to have the possibility to use the radar sensor images, and you perfectly understand why. You have discussed this issue from the technical point of view. So this was considered something necessary to complement the capability of the optical sensors. The second one was the space agency that represents the interest of the government to get at the time, an observation system. And the third main actor is the industry, because we have to consider that what has been achieved was achieved because there was a strong belief at the time in industry to transfer the capability that they had about the radar techniques that they use for ground radars to the space. And so this make possible the success of the program. So at the end, the first official agreement between the Space Agency and the Ministry of Defense was signed in 2002. And after that, as you know, there were the launch of the 4 satellites. That are now all operational since 2009. So we are working on this system since 2007. So we can say that we have an experience over 5 years. Now, in order to get these results, if we want to summarize which are the main elements on which we base this program, we try to summarize in 4 main pillars. The first one is the user requirement harmonization. Second one is the joint governance. The third area, we put in this area all the agreements and procedures and what includes, as it was said before by my colleague, the data policy, the source sharing, priority management. The area of agreements between inside the organization. And then at the end, the security provisions. So we think that these are the main ingredients of this program. Starting from the first one, how was possible to merge the different requirements coming from the defense side and from the civilian side? We think that it was possible because of the complementarity. Complementary, what it means? Means what we try to summarize in the fact that from the defense point of view, the focus is not in the number of images, but in the priority. So to have, in few words, the right image at the right time. While on the other side, due to the fact that under the civilian side, there was a need for a huge amount of images for different kind of users. So There was not a focus so stringent as for the military side on the time. So this made it possible the merge of the two requirements. Of course, to achieve this target, the performance of the system must be able to satisfy in terms of operative versatility. That means that the SAR can be used in different operative modes. And the system must have a high duty cycle because it has to support a large amount of data required by the wide user community. And last, the capability to manage different classes of users. Second point is the joint program office, the joint governance that is based, for sure, on joint program office. This is what came to my mind because I'm part of this organization. And this organization must cover all the life, starting from the very beginning to the operational phase, as it was already addressed by my colleague of the Space Agency. And for doing that, I think that the partners must share a coordinated vision. And they have to establish, for sure, a joint organization and the procedures to manage both the procurement phase and the operational phase. And one of the challenges was to optimize the different competencies coming from different backgrounds, as you can imagine. This is, in this chart, we summarize in the first phase that we call procurement phase, the organization. And this slide summarizes the structure in the operational phase. You see there is a coordination board, a strategic level, then below there is a mission director that is responsible for the management of the system, and the mission director is supported by the community of users, and MCO stands for maintenance in operational conditions. So the people that is in charge to provide the service level required for the system. Then there is the area of the agreement that as was already anticipated, and the main issues related to the agreements are referred to the data policy, that means who can have access to what kind of data, the resource sharing that involves the partitioning of the system between the defense and the civilian users, but also between the Italian stakeholders, that we are the Italian stakeholders, and international partners. And then the management of priority for the different classes of users. 2 minutes. Speed up. Security provisions. The last ingredient is the security, for sure. This is mandatory for the defense side, but also the civilian part takes benefits from these provisions. And mainly this includes the protection of the spacecraft, the creation of 2 different domains for civilian and for the defense, and the shielding of information. And here we are at the lesson learned. So after the 5 years of use of the system, we can say that we come to the same conclusion that COSMO-Skymed was a success. And we can say that the civil defense duality paradigm was possible because we strongly believe in the common program management. This is the key of the success, in my opinion. And this represents not only, say, the validation of the concept, but also a sort of model that we propose for consideration to other partners, to other international partners. The second point of the success, for sure, was the fact that the cost sharing and optimization of resources obtained consistent savings. And this is very important in terms of money, in terms of human resources. It was a success because we succeeded in implementing the services approach that was described by Mr. Maranesi and Mr. Kamiyama, because of course this system is service oriented, and this means that there was a clear understanding of the user needs. And so we think at the end that this system is attractive for foreign partners. This is what we think. And now we're looking at the forthcoming Cosmos second generation, and this is a good opportunity that we expect to improve the implementation of the duality concept based on the lesson learned on the first generation. And this comes to my conclusion. Finally, we think that COSMO-Skymed represents the proof that the dual-use system can be the right solution, the viable solution, of course, provided that you have the technology for doing that. And we believe that we have created a model, the paradigm for cooperation between military and civil world, and this model can be also considered as option for other countries. Thank you for your attention.
Thank you very much, Mr. Rivola. And now our last speaker for the day, Mr. Denis Murat from the European Defence Agency. Mr. Murat, the floor is yours.
Thank you, ladies and gentlemen, dear colleagues. I intend to present my views in addressing, I will say, 2 points. First of all, I will want to reassess some messages which have been presented before, of course, for highlighting the importance. And I will also address the question I have been asked to address, which is the vision for dual-use system in the future. I think you have understood with the presentation you have got, but more important with the images you have got, that Earth observation from space is a must for situational awareness, or if you prefer, crisis management. These type of applications, in fact, are covering several layers or several aspects. The civilian aspect, you have seen that. The military aspect, you have seen that also. There is also a political level, which is probably very important also to consider, because after all, when you are dealing with that kind of sensible data, product, information, and so on, you have to think about the political consequence of releasing that kind of information and so on. That's something which is important to consider, particularly when you are addressing the data exchange, the data distribution, and so on. Staying on this point, dealing with crisis management, we are speaking about saving people, saving life, saving time and money. You have seen that the government from Brazil got a lot of benefits. However, I will want also to insist on the fact that we are dealing with crisis management about anticipating risk. Risk mitigation is perhaps more important than only addressing the risk consequences of an event. And this risk mitigation is asking for continuous effort, which is, I think, also providing a strong argumentation for developing these programs. Another point I want to address is the fact that, as most of the other space applications, the associated technologies for Earth observation are of dual use, means they have application for purely civil system, for purely military system, and for dual-use systems. However, and it is perhaps more important for Earth observation, in case of military specific applications which are critical, such as intelligence, we must also recognize that there are some specific processes, technologies, and so on, which are completely different from the civil world. And I think it is one of the, how to say, plus of the COSMO-Skymed program to have solved these issues, which are quite complex. This brings me to the point that, as I was saying at the very beginning, the political aspect implies that you have to deal with data policy governance. It has been expressed previously. And I had one other dimension, sovereignty. means the national interest. It is important to consider because, of course, when you are addressing a system for national users, you do not have to solve that kind of problem. But as soon as you are speaking about corporation, which may be exchanging data or having some interface with other systems and so on, you are facing very difficult problems, I think. And perhaps I will jump also on the previous presentation in recalling that even if the situation is not always simple, Italy and France have developed now some, I will say, common approach for trying to solve this aspect now, today, thanks to the offer program, but also in future because we are working together on the next interface, I will say, between the second generation of COSMO-Skymed and the new generation of the French system. This political or sensitivity dimension, as a consequence, you have to know that some countries, it is true in France, in Germany, in the States, in Canada, I am not so sure it's fully integrated in Italy, but there are now national laws for the distributions of these images. So in Italy, I think it's not a law. It's at the level probably of the interministerial agreement. And just to be short, when you are dealing with images with a resolution lower than 5 meters, in some countries, you must ask explicitly an authorization for distribution, exportation, and so on. Typically, for images below half a meter for optical band and below 1 meter for radar, you have to cope with national laws for distributing, for exporting, and so on, these images. And of course, when we are speaking of dual use, this is a consequence which is limiting the possibility you have to make distribution outside your country, and even inside your country. Okay, a point now dealing with the presentation of our Japanese colleague is the fact that it is now, I think, universally agreed that the merging of images or data from different sources is, for example, optical and radar, is putting a lot of advantage in terms of performances. I mean, understanding what's in these images, but also in terms of political awareness of exchanging data, particularly true between France, providing optical images, and Italy, providing radar images. It is obvious for every country that achieving that kind of merging between several sources is today absolutely a must. And tomorrow, in addition to optical and radar, we will have another, I will say, branch with hyperspectral images that will add another dimension. Now, I will address the last point I wanted to reinforce, the fact that the Italian COSMO-Skymed system is an important tool for Italy, but also for Europe. It has been slightly mentioned, but there is a direct link with the European Union Satellite Center, which can get, under special conditions, of course, some images coming from the system for the so-called European security and defense policy. There's this dimension, which is not only national, but at European level. I think it's important to recall. Now I will try to address the question I have been asked to answer. What are my views concerning the future of dual-use system? It's a difficult question, because the world is changing fast, and we can see that, for example, in the States, the merging between two competitive commercial companies is likely changing also the scope in Europe. However, we can consider that probably not in the medium term, but in the long term, we may have 3 types of system. The purely civilian one, which probably will be mainly private, that is to say funded by industrial companies developed in a competitive market. That is to say, you will have to fight with other providers, and the cost issue will be very important. On the other side, you will have military systems. Today it's quite difficult to consider that some specific activities such as intelligence, which is still today very national, can be done in a very open process, I will say. And there's the countries who will have the capacity, the financial, the technical capacity, to have this system will likely keep on developing and operating their own system, but probably much more focused on this sensitive application in intelligence than making everything. And in the middle, we have the so-called dual-use systems, which have probably the most important feature because they are the widest. And since they are the widest, probably the best idea we may have in terms of funding is to think about that kind of approach which has been developed for telecommunications and which is called PPP, for public-private partnership, under governmental control. This second part of my sentence is very important. You are dealing with sensitive information. You cannot expect that when you are dealing with images a few meters or below resolution, the market or the process and so on will be completely open. However, probably also for this kind of dual-use system, there will be some competition. It's an approach which is now followed in some countries, of course in Italy, but also in France. Pléiade is a dual-use system, in the States. And since the basic idea for having the merging of public and private fundings is also a view of commercial business case, there will be competition also. And that's why also the dual-use system will have to take care about the cost. That's my main message for today.
Thank you very much, Mr. Morin. So we have time for a couple of quick questions and quick answers as well. Yes?
Antonio Moccia, University of Naples. I was very impressed by presentation from Japan space imaging, because they have a real interesting approach on optical and microwave data fusion and in providing application services in that field. And I would like to ask to our Italian colleagues if they are forcing some kind of this kind of product. I appreciated the data over Emilia earthquake, but it was an aerial data with microwave. I mean space, optical, and microwave data fusion.
Yes, maybe I was not much clear in my presentation. I showed only the aerial image over Emilia, but of course we have collected also the radar part. And actually all these applications that I presented are a combination of optical and radar. For example, in the maritime, which is mainly radar for detection, then becomes also optical when you want to see better some ship in a harbor, or if you want to monitor, for example, the site, the coastal site that generates illegal immigration. So the use is not only just overlapping on the same area, optical and radar, but it's also a different acquisition collection strategy in order to monitor, to, let's say, detect certain behaviors and situations. For sure, it's a combination of all these tools.
Any other questions? Okay, I think we come to an end. I'd like to thank all the speakers. I think this was a very good meeting. It looks like I like the conclusion by Mr. Murat, and I think we all agree that the dual approach is quite challenging, though with lots of added value then at the end. Thank you very much, and you have a great afternoon.